Hello my dear students, today we are going to discuss some of the most important questions from the chapter laws of motion, and all these questions are from the previous year papers only. Here comes the first question. A small ball of mass m is thrown upward with a velocity of small letter u from the ground. Okay, the ball experiences a resistive force m times kv square. So that is a force where v is the speed, and the question is the maximum height attained by the ball is. So here, in addition to the gravitational force, I repeat, in addition to the gravitational force, there is one more force acting, that is what? mkv square. So let us consider that first. So the forces acting are m into g, other than that m into k into v square. As per the question, these are the two forces acting. So of course, the net downward acceleration, A is going to be what? A is supposed to be kv square plus g. So that is going to be the net downward acceleration experienced by the body. Okay. Now the question is, what is the maximum height attained? I repeat, what is the maximum height attained? So if I take this as the ground, and let me consider this body is thrown with a speed of u meter per second. Initial speed is u, and of course reaching here the final speed is going to be what? 0. Now somewhere here let v be the speed. I repeat, let v be the speed. Now as per the question, the acceleration experienced by the body is supposed to be what? Acceleration experienced is A is equal to kv square plus g. And we all know that acceleration A, that is v into dv by dx. I repeat, v into dv by dx. So here dv by dx is negative. So I need to write this as A is equal to minus of v into dv by dx, that is equal to k into v square plus g. Now if I rearrange this, I can mark this as v into dv upon k into v square plus g, that is equal to minus of dx. Okay. Now if I integrate this, what is the initial value? Initial value is u. Initial value is what? Small letter u. And what is the final value? That is 0. So here the limit is going to be from u to 0. v dv upon k into v square plus g, that is equal to minus of integral of dx between the limit 0 to capital H. If you integrate this and substitute the limit, you will get the answer as option B. Okay, where u is the initial velocity and capital H is going to be the maximum height. Here comes the next question, number 2. The question says, an insect is at the bottom of a hemispherical ditch of radius 1 meter. It's a hemispherical ditch, and it crawls up the ditch but starts slipping after it is at a height of small letter h from the bottom. If the coefficient of the friction between the ground and the insect is 0.75, then h is, that is a question. So here let this be that hemispherical ditch. Okay, fine. So let this be the point from where it started moving, and let this be the center, and let me assume at this particular point it start feeling slippy. That means above this it cannot go up. Okay, so let me mark this as the angle theta. Now here let this be the ground. Okay, now if I draw a tangent here, so if this angle is theta, this one also going to be what? Theta. This is a hemisphere, that's why. Now at this particular point, so you all know that here this is theta. Okay, now I can say tan of theta, what it is? Dy by dx. Okay, and as per the condition of angle of repose, we know that this tan of theta, that is equal to dy by dx, that is equal to what? Mu, coefficient of friction. And what is coefficient of friction here? Coefficient of friction is given as 0.75. 0.75 can be written as what? 3 by 4. Okay, don't get confused. We are discussing the same concept of angle of repose. Okay, if any particular body is kept over here, the maximum value of theta that we can have here is tan of theta, that is equal to what? Mu. The same concept what I am applying here. So here that inclination is mentioned just by considering the case of the scrolling insert, that's all. Is that okay? Yes. So mu is equal to what? 3 by 4. Okay, now here if this particular body is at state of rest, that means we know that mg sin theta will be acting in the downward direction, and of course friction will be acting in the upward direction. Now I can say that mg sin theta, isn't it? Mg sin theta, that need to be equal to what? Mu times mg cos theta. That is how, that is at equilibrium condition. But our point was not that. Our point was, what is this height? What is this height? Okay, that was the point. So here we got to know about theta value. What it is? Tan theta is equal to 3 by 4. Now what I am going to do is, see, in this condition, if I drew a straight line like this, so I told you this angle was theta. Okay, in that condition, if I take this as capital R, so what this is going to be? Here this is going to be R cos theta. So here this is what? This is small letter h. So it's very clear, small letter h plus R cos theta, that's equal to what? Capital R, or I can say h is equal to R is common, 1 minus of cos theta. Okay, now we know that tan theta, that is 3 by 4. So here this is 3, here this is 4, and here this is 5. Okay, now h is equal to, what is R value? Capital R is given as 1 meter. Okay, so 1 into 1 minus of, what is going to be cos theta? Cos theta is going to be 4 by 5. 4 by 5. Okay, so here I can say that small letter h is going to be 5 minus of 4 by 5, that is 1 by 5, that's going to be what? 0.2. 0.2. Checking the option, it need to be option D. I believe that was okay. Now let's move to the next, that is question number 3. Question number 3 says, a bead of mass small letter m stays at point P equal A comma B on a wire bent in the shape of a parabola given by the equation y equal to 4 times cx square and rotating with an angular speed of omega. Okay, now the value of omega is, so it is at state of rest there. Okay, so the value of omega is, that is what they are asking to us. All right, so this is that wire. Okay, and here the body is, and this point is marked as what? It is marked as A comma B. small letter a comma b, and the equation of parabola is given as y equals, okay, 4 into capital C times x square. This is the equation. Are you getting me? Now, this particular setup is rotating with an angular speed of omega. So, of course, this particular mass over here, that will be experiencing a force in the outward direction. And I can mark that force as m into r omega square. M into r omega square. And what is r here? R is equal to small letter a. So, I can say that force acting outward, we call it as centrifugal force. That is what? M into a into omega square. M into a into omega square. Now, let me consider this point. Okay. So, if I consider that mass again, let this be that part and let this be the mass. If I draw a tangent here theta is going to be the angle. Okay. Now, this force acting is m into a omega square. If this angle is theta, this one is also what? Theta. Now, if I resolve this force, that is, if I resolve this ma omega square, it's going to have two components. One is going to be ma omega square cos theta in the upward direction, and the another one is ma omega square into sin theta in the downward direction. That will offer the normal reaction. Other than that, there is one more force acting, that is mg sin theta, that is in the downward direction, and of course mg cos theta is going to be in the downward direction, and altogether this offers the normal reaction. Okay, normal reaction is not a matter of concern for us. Now, if I consider the equilibrium condition, I repeat, if I consider the equilibrium condition, along this axis it is not accelerating, as well as along this axis it is not accelerating. I repeat, along this axis it is not accelerating, as well as along this axis it is not accelerating, but this is rotating like this. So, considering the equilibrium along x axis means the one along the direction of ma omega square cos theta, that is, I am taking it as x axis. So, here ma omega square into cos of theta, that is equal to what? Mg sin theta. That is keeping this body in equilibrium along x axis. So, here m and m will cancel each other. M and m will cancel each other. Now, a into omega square, that's equal to what? If I take this here, that's going to be equal to what? G into tan of theta. Sin theta by cos theta is tan theta. Fine. Now, the question here is, we need to get the value of omega, and you can check here, the sin theta cos theta term is not at all there. Only the terms what we are having over here is G, C, A, B. Which means we need to get the expression for what? Tan theta here. We need to get the expression for tan theta here. I'm sorry. We need to get the expression for tan theta here. So, to get that, of course, we have got the expression for y is equal to 4 times c into x square. Now, we all know that tan theta, that's equal to what? Dy by dx. Tan theta is equal to dy by dx, and that is equal to what? 4 2s are 8 c into x. So, dy by dx is 8cx, and here we are at x equal to what? We are at x equal to a. I repeat, we are at x equal to a, which means considering this, tan of theta equals what? Tan of theta is equal to 8 times c into a. Now, let us go back to this. We have got, a omega square, that is equal to g tan theta. G into, instead of tan theta, I am going to write as what? 8c into a. A and a will cancel each other. Alright. So, omega square is now g into 8 can be written as what? 4 into 2 into c, which means omega equals 2 into root of I repeat, 2 into root of G into C into 2. That is omega equal 2 root of 2gc. 2 root of 2gc. 2 root of 2gc. That means option A is going to be correct answer in this case. Now let's move to the next, that is question number 4. Question says, an inclined plane is bent in such a way that the vertical cross section is given by y equal to x square by 4, where y is in vertical and x is in horizontal direction. If the upper surface of this curve is rough with a coefficient of friction equals 0.5, then the maximum height in centimeter at which a stationary block will stop slipping downward is. That is a question. So here again we are going to consider the concept, that means tan of theta, that's equal to mu. Okay, tan of theta, that means the slope must be maximum up to what? Mu only. So precisely saying tan of theta max, that should be equal to what? Mu. That is the condition. Okay. Now what we have? We have got the equation as y equal to x square by 4. Y equal to x square by 4. So what is going to be dy by dx? Dy by dx, that is equal to tan theta. Okay, that is the slope. That's going to be what? 2 into x by 4. That is what? X by 2. So tan theta equals to x by 2. That's equal to what? What is the coefficient of friction? Coefficient of friction is given as 0.5. That is 1 by 2. So this one and this one will cancel each other. Okay, which means x max equal to what? 1. X max equal to 1. Our question is up to what maximum height it can reach, which means we need the value of y max. So y max, that's going to be x max is what? X max is 1. 1 by 4. That is 0.25. Okay. So we need answer in centimeter, I believe. So 0.25 meter, or it is 25 centimeter. I believe that was okay with you. Let's move to the next, that is question number 5. Question number 5 says, of course this is a statement type question, statement number 1 and statement number 2. Let's see what is statement number 1 saying. A cyclist is moving on an unbanked road with a speed of 7 km per hour, unbanked road, and takes a sharp circular turn along a path of radius of 2 meter. Radius is 2 meter without reducing the speed. The static coefficient of friction is 0.2. Cyclist will not slip and pass the curve. That is statement number 1. And they are asking us to take the value of G is equal to what? 9.8. Of course, here in the first case there is no banking. So let's consider the case where cyclist taking a horizontal turn. So let this be the cyclist. Let this be the cyclist. Okay. Now the necessary centripetal force is going to be provided by what? Friction. So F is equal to mv square by r, that will be offered by mu into n. Okay. Now here, what is the speed? Speed is 7 km per hour and mass is not at all mentioned, and here in fact we don't need that, isn't it? Why? Because here v square by r, that's equal to mu into g, because m and m will cancel it, because n is going to be what? Mg here. I repeat, capital N is equal to m into g. M and m will cancel each other. That is going to be what? Mu into g. Now here v square, that's equal to what? R into mu into g, and v is going to be what? Root of mu r g. This is the maximum speed that what they can have. And here this is going to be root of what are the parameters given? Like radius r is given as 2, isn't it? So radius r is 2, and coefficient of friction mu is equal to what? Coefficient of friction is equal to 2 by 10. So it's going to be 2 by 10 into here g is 9.8. Alright. So here of course this will come out as 2, and here this is root of 9.8 by 10. Okay. Now what they are saying here is the maximum speed they can have is what? 7 km per hour. Now just have a look. 7 km per hour, if I convert to meter per second, is going to be what? 7 into 5 divided by 18, isn't it? So here this is 35 divided by 18. Okay, fine. Definitely this is going to be a value which is less than 2, because 18 into 2 is 36. So definitely this is going to be value less than 2. Okay, and here if you compare this one, fine, statement 1 can be proved as true. Alright, now come to the next. Statement number 2 says, if the road is banked at an angle of 45 degree, if it is banked at an angle of 45 degree. So here, if it is banked, then what is the value of V max? V max is R times G into root of mu plus tan theta upon 1 minus mu tan theta. I repeat, V max is equal to Rg into root of mu plus tan theta upon 1 minus mu tan theta. That is a general expression. And what is tan theta we are having? Tan theta what we are having is 45, and mu is marked as what? 0.2. Mu is marked as 0.2. And statement number 2 says it can have a maximum speed up to 18.5 km per hour. Now, in this condition, if you go ahead with this calculation, okay, so here V max, that is going to be what? R is 1, R is not 1, R is 2, R is 2. R is equal to 2 into 9.8 all divided by, what about the mu value? Mu value is 0.2 only, isn't it? Yes, 0.2. So 0.2 plus tan of 45, that is 1, all divided by, here this is 1 minus of again 0.2. So here this is 2 into 9.8 all divided by, here this is what? 1.2 upon here this is 0.8. Okay, and here you will get this as 2 into 9.8 divided by root of, here I can mark this as, let me multiply it with 10 and divide with 10. So here this is going to be what? 12 by 8. Okay, you are going to get it as 12 by 8, and here it's marked as 18.5 km per hour. Okay, what it is? 18.5 km per hour. This is in meter per second. Okay, so here 18.5 into 5 by 18. This particular value, if you solve, you are going to get this as approximately 5.4. And if you solve this, you will get it as approximately 5.1. Okay, so the what you are going to achieve is 5.1 something, and the maximum allowed is 5.4, which means statement 2 is also what? Correct statement only. So here statement number 1 is correct and statement number 2 is also correct. That means option 4 is going to be the correct answer. You need to be specific here with what is going to be the maximum speed for horizontal road. So for the horizontal, let me clear the takeaway for these two cases. For horizontal, V max is under root of mu times R into G, and for an inclined plane, meaning inclined road, that means the banking is provided, their V max is equal to R into G root of mu plus tan of theta all divided by 1 minus mu tan theta. That is a relation that you must keep in mind. Okay, so that is the takeaway for this question. Now let's move to the next, that is question number 6. Question number 6 says two blocks of mass m equal to 0.5 kg and capital M equal to 4.5 kg are arranged on a horizontal frictionless table as shown in the figure. The coefficient of static friction between the two blocks is 3/7. Okay, then the maximum horizontal force, the question is maximum horizontal force that can be applied on the larger block, that is one on the bottom, okay, so that the block move together is, that is a question. So here let us consider the arrangement like this. Here I am applying the force, and here this is small letter m, here this is capital M, and capital M is of mass 4.5 and here this is of mass 0.5, and there is no friction between these two surfaces. No friction is there between these two surfaces. So these two masses, small letter m plus capital M, all together it gives a mass of what? 5 kg. So 5 kg mass is going to move with an acceleration of a towards right under the influence of force capital F. If I consider the motion of this all together without any slipping, the total mass is what? Total mass is 5 kg, and 5 kg mass is moving towards right with an acceleration of a. So I can say that acceleration A is equal to what? F by m, and that is 5. Now, of course, if I consider the mass motion of this small letter m, that small letter m mass is moving also with the same acceleration a, but only by the friction of F. Okay, and what is that F max? F max is supposed to be mu into m into g. Alright, now what is mu here? As per the question, mu is 3/7. 3/7 into what is m? M is 0.5. I can write it as 5/10. Okay, and acceleration due to gravity, I am going to take it as 9.8. That is F max. Okay, and this F max is supposed to be equal to what? This F max is supposed to be equal to m into a. That is small letter m, that is 5. What is a? A is F by 5. A is F by 5. I believe you are getting it. Okay. Now here this is F max. F max is equal to m into a. Okay. Now, of course, this one and this one will cancel each other. Now, further considering the cancellations, this will get cancel each other. Okay. Now capital F is coming as what? 3 into 9.8 all divided by 2 into 7. Okay. Now, let me take this as 98 into 3 all divided by 2 into 7 into 10. Alright. So, here this is going to be what? Of course, if I cancel these two, here this is going to be 49. Alright. And here this is going to be what? 7. Okay. Now here this is going to be what? 7 3s are 21 divided by 10. Okay, fine. So if to the nearest integer they are asking, alright. So I am going to get this as what? 2.1, which means F is equal to what? 2 Newton approximately. Equal to 2 Newton. Again we can cross check this. How? Have a look. Here we are getting it as what? 9.8. Let me take this as approximately 10. So 3 into 10 all divided by 2 into 7. Okay. Now have a look. Of course this one and this one will cancel each other. Here this is going to be what? 5. 5 3s are 15. 15 by 7. Okay. In that way also we can proceed with the calculation. Okay. Approximately is coming close to 2. Now let's move to the next, that is question number 7. Question number 7 says a body of mass 1 kg rests on a horizontal floor with which it has a coefficient of static friction equals 1 by root 3. Okay. Now if it is desired to make the body move by applying a minimum force possible, capital F, then the value of F is, that's the question. So here the condition is we need to apply minimum force. While applying minimum force, the concept is not only just to move the body in the horizontal direction, we need to understand that applying the force, if you want to move the body in the forward direction, we need to overcome the friction. Overcoming the friction, it has got of course the contribution of the horizontal force. Other than that, the friction is by the virtue of normal reaction. So our force need to be applied in such a way that we can reduce the value of normal reaction and can contribute more onto what? More onto the horizontal component. Okay. So while doing so, I am going to create the situation here like this is the body and I am going to apply a force F here, alright, and M into G, that is the weight acting. Now if this particular force is at an angle theta, so F cos theta is going to be the horizontal component and F sin theta is going to be the vertical component. Okay, and let F be the friction. Now to make this body move in the forward direction, capital F, that need to be equal to what? F cos theta. And what is F? F is mu into n, that is equal to F cos of theta. Now what is the value of capital N? Capital N equals mg minus of F sin theta. Now let me substitute that here. So mg minus of F sin theta, that should be equal to what? F cos theta. Now here you can see capital F, it's function of theta. If you differentiate this, df by d theta equal to 0. Here you will get theta is equal to 30 degree. That means the minimum value of F is possible for theta equal to what? 30 degree. Substitute that over here. Doing so, here you will get it as M into G minus of capital F into sin theta. Sin theta is 1 by 2. That is equal to here capital F into cos theta. Cos theta is root 3 by 2. We are going to get it like this, isn't it? I believe we are missing that mu term. Mu term is missing here. Okay, mu term is missing. So that mu part need to be here. Alright. So we need the value of what? Capital F. So M into G minus of F by 2, that is now equal to F into under root 3 by 2 upon mu, because this mu will go down. Now M into G minus of F by 2, that's equal to F upon What was the value of mu? Mu was 1 by root 3. Mu was 1 by root 3. So 1 by root 3 means root 3 is supposed to be on the top into under root 3 by 2. Here this is supposed to be what? 3 only. So m into g, that's equal to, this will go to the right. So that's going to be f by 2 plus, here this is 3f by 2. Alright. So here this is what? Of course 2 times f. Okay. Now we have 2 times capital F, that's equal to m into g. Now capital F equals mg by 2, and what was m into g? M is 1, g is 10. So here this is 10 by 2, which means 5 Newton. So the maximum value of force that we can apply is what? 5 Newton. Okay. Moving to the next, question number 8. The question says, a particle of mass capital M originally at rest is subjected to a force whose direction is constant. I repeat, the direction is constant, but the magnitude varies with time according to the relation capital F equals to F naught into 1 minus of smaller t minus capital T by capital T the whole square. Okay, where F0 and capital T are constant. Okay, now the force acts only for the time interval 2t. That is very important. The force is going to act for time interval 2t. Now the question is, velocity of v of the particle after 2t is. That's a question. Have a look. Here the force is given as F is equal to F naught into 1 minus of smaller t minus capital T by capital T the whole square. Okay. And what is this F? F is supposed to be capital M, that is a mass, into acceleration A. So I am going to consider that. That means capital M into A, that is equal to F naught into 1 minus of smaller t minus capital T upon capital T the whole square. So here this is acceleration A, which can be written as dv by dt. That is equal to F naught upon capital M into 1 minus of, I am going to take this capital T square out, and here this is going to be smaller t minus of capital T the whole square. Okay. Now I am going to take this towards the right. So dv is now equal to capital F naught upon M. I am going to take this as a constant. Okay. I am going to take this as k now. K into, alright, 1 minus of 1 upon t square into, here this is what? T square plus capital T square minus of 2 into smaller t into capital T. Okay, into dt. I believe it's almost clear now. We need to integrate it from 0 to v. So here this is going to be integral of dv 0 to v, and here this is going to be k into, k I told you what it is, k into integral of 1 minus of 1 by t square into smaller t square plus capital T square minus of 2 times t into capital T into dt between the limits 0 to 2 times t. Because acceleration is acting for time duration 0 to 2 times t only. Now here if I proceed, on the left hand side it is going to be v, that is equal to, on right hand side I have got that capital K out, capital K into, okay, here this is 1, this comes in, that is going to be integral of dt. Integral of dt is what? Smaller t between the limit 0 to 2t minus of, I have got 1 by t square here. So 1 by t square is going to be there, integral of 0 to 2t, Okay, what all I have? It's t square into dt, small letter t square into dt plus capital T square into dt, capital T square into dt minus of 2 times small letter t into capital T into dt. 2 times small letter t into capital T into dt. That's what there. Okay. Yes. Now let me proceed. Here this is going to be again k into, here this is small letter t between the limit 0 to 2t minus of 1 upon t square. I am not going to apply the limit. Like right now I am not going to apply the limit. Now let me solve this first. Here this is going to be what? T cube by 3. Small letter t cube by 3 between the limit 0 to 2t plus, here this is going to be t square into integral of this is small letter t, again between the limit 0 to 2t minus of 2 into capital T into t dt. Integral of small letter t into dt is going to be what? T square by 2. This one and this one will cancel between the limit again 0 to 2t. Now I am going to apply the limit. So here this is capital K into applying the limit, here this is going to be what? 2t minus of 1 upon t square into, that's common. Now let me apply the limit. If I apply the limit, here this is going to be what? 2 to the 4, 8t cube by 3 plus, here this is t square into, this is going to be what? 2t only, 2 times t minus of t into, here this is 2t square. 2t square means what? 4t square. Alright. So here this is 2t cube and here this is what? 4t cube. So that is minus of 2t cube. So if I further solve this, I can say this as v equals k into, here I have got 2t, 2 times t minus of, here I have got 1 by t square, okay, into, here this is 8t cube by 3, 8t cube by 3 minus of, here I have got minus of 2t cube, minus of 2t cube, isn't it? Here this is going to be minus of 2t cube because I have got 4t cube here, minus of 4t cube here and 2t cube here. That's why this is minus of 2t cube. Alright. Now further I solve this. Here this is going to be k into 2t minus of 1 upon t square into, I have got this as 8t cube minus of 3 to 6t cube all divided by 3. Okay. Here this is k into 2t minus of 1 upon t square into, solving this, here this is supposed to be what? 2 into 2t cube divided by 3. 8 minus 6 it is 2, 2t cube by 3. So here t square and t cube will cancel. Only this part will be left, isn't it? Now here this can be written as v equals k into, okay, here this is what? 2t, alright, minus of, I have got here what? 2t by 3. Alright. So 3 2s are 6, 6 minus 2 is 4. So v is coming as k into 4 times t by 3 2s are 6 minus 2 is 4, 4t by 3. And tell me what was k? K was f naught by l. It was f naught by l. So v is equal to f naught by m into 4t by 3. F naught by m into 4t by 3. Alright, f naught by m into 4t by 3. F naught by m into 4t by 3. Option C must be the correct answer here. Was that okay? Now let's move to the next, that is question number 9. The question says the boxes of 2 kg and 8 kg are connected by a massless string passing over a smooth pulley. Calculate the time taken by the box of mass 8 kg to strike the ground starting from rest. So here this is 8 kg mass. This is 8 kg mass and here this is 2 kg mass and we have got what? 20 centimeter height. Okay, so let's recreate this diagram. So here we have got one string coming like this and I have got a pulley here and this is the mass. Now let this be second string and pulley and here this is the first mass and it's connected like this. Okay, so here this is 2 kg and here this is 8 kg and this is 20 centimeter. Okay, so if this is tension T, then here also this need to be what? T, here also this need to be T and here this is supposed to be what? 2 times T. Okay, so let this be acceleration A1 and let this be as, let me mark this as A2. Now from constraint relation we can get the relation between A1 and A2. We can get the relation between A1 and A2, isn't it? So that relation is 2 times A1 is going to be what? A2. I repeat, 2 times A1 is going to be A2. Now what could be the value of A2? For that what I am going to do is I am going to consider the free body diagram of this 2 kg mass. So while considering the free body diagram of 2 kg mass, here this is tension T and here this is 2 kg, I would like to mark it as 20 Newton downward and acceleration is A2 upward and here this mass is what? 2 kg. Okay, mass is 2 kg. Now if I go ahead with the equation of motion of this one, mass is 2 into acceleration is A2. So m into a in the upward direction is upward force, that is T minus of what is this force? Here it is 20. Alright, yes. Now if I consider the motion for the second mass, that is 8 kg mass, their 8 kg mass is coming down with an acceleration of A1. So 8 is coming down with an acceleration of A1, that is equal to downward force is going to be weight of 8 kg mass, that is 80 Newton, minus of what is force acting in the upward direction? 2 times T. So here this is the free body diagram. 80 Newton is acting in the downward direction, 2 times T is acting in the upward direction and here this is coming down with an acceleration of A1. This is that equation is. And we have got the relation between A1 and A2. What it is? A2 is equal to 2 times A1. So I am going to substitute that here. Okay, while doing so, 2 into what is A2? A2 is 2 times A1. Okay, that is equal to capital T minus of 20. Okay, so here this particular relation can be further modified as, okay, 2 to the 4 times A1, 4 times A1, that is equal to T minus of 20, T minus of 20, and we are having another relation here. What it is? Sorry, we are having another relation here, that is 8A1, 8 times A1, that is equal to what? 80 minus of 20T, 80 minus of 2T, 80 minus of 2T. Let me multiply this relation with 2 on the left hand side and multiply this with 2. So here this is going to be what? 4 2s are 8 A1 again. That is equal to, here this is going to be 2t minus of, here this is going to be what? Minus of 40. So if I add these two relations, here this is going to be what? 16 times A1, that is equal to plus 2t and minus 2t will cancel each other. And summation of these two is going to be what? Is going to be plus 40. We all know that here this can be written as what? 4 into 4 into A1, that's equal to what? 40. Here this one and this one will cancel each other. Here this is going to be what? 10. So A1, that's going to be what? 10 by 4, or I can say it is going to be what? 5 by 2. So we got the value of what? A1 now. Okay, it's not over yet. Now here this was the body and this was at a height of 20 centimeter. I can say 2 by 10 meters. I repeat, 2 by 10 meters. Now what is the time taken by the body to travel from here to here? That was the question. Yes. So I can say that now from the relation S is equal to ut plus half at square. For this relation u is equal to what? 0. And S is supposed to be what? 2 by 10. That is equal to half of acceleration. I am going to take it as what? 5 by 2 here. Okay, it is 5 by 2 into t square. Is that fine? Yes. Now doing so, what I can have is this one and this one will go. Here this is going to be what? 5. Rearranging this, here this is going to be what? 2 2s are 4 and here this is what? 5 5s are 25. That's equal to t square, or I can say t is equal to what? 2 by 5. T is equal to 2 by 5. Okay. Now of course 2 divided by 5. Okay, it's supposed to be what? 20 by 5, that is 0.4 second. That means option 4 must be correct answer in this case. Is that fine? Now let's move to the next, that is question number 10. Question number 10 says, statement number 1, two forces P plus Q and P minus Q. It is P plus Q and P minus Q, where P perpendicular to Q, that is important, a P is perpendicular to Q, where act at an angle theta 1, so theta 1 to each other. Now the magnitude of the resultant is root of 3 times P square plus Q square when they act at an angle of theta 2, and the magnitude of the resultant becomes root of 2 times P square plus Q square when it is at theta 2. At theta 1 it is root of 3 times P square plus Q square. Okay, and at theta 2 it is root of 2 times P square plus Q square. This is possible only when theta 1 is less than theta 2. And statement 2, in the situation above, theta 1 is equal to 60 degree and theta 2 is equal to 90 degree. These are the two conditions what they are saying. So let's try to understand the situation here. As per the question, P and Q are perpendicular to each other. So I am marking it like this. Okay, fine. So here this is magnitude of P plus Q. So that is under root of P square plus Q square. Okay. Now let me mark this as S. Now here this is P and here this is minus of Q. And this is supposed to be the magnitude of vector P minus of vector Q. Again, the magnitude is going to be what? P square plus Q square only. So here also what? It's going to be S. Now, what I am going to do now is, here this is S and here also this one is S. Fine, magnitude wise both are the same, but Since I would like to mark this as two different vectors, I would like to name this as vector A and vector B. Vector A and vector B. Okay. And I told you magnitude of vector A is equal to magnitude of vector B. Magnitude of vector B, that's equal to what? S. I believe that is okay now. Alright. Now, try to understand the situation here. What they are saying. When they were at an angle of theta 1, the resultant is root of P square plus Q square times 3. Okay, fine. So, let me consider that case here. What was S square? S square was P square plus Q square. Alright? Yes. Now, if those two vectors, like vector A and vector B, if it is an angle of theta 1, then the magnitude of the resultant R1, that is supposed to be what? That is supposed to be A square plus B square plus 2 times AB cos of theta. And I told you the magnitude of this is what? S. So here this is root of S square, this is S square, this one is also S square, and this one is also what? S square. So S square is common. Okay, S square is common. Now what we have here is, just have a look, all these terms were S square only. Now this is supposed to be what? Here this is supposed to be 1 plus 1, that is 2. Okay, and I have got another 2 here, and here this is what? Cos of theta. Cos theta. Fine. Now again 2 is common. So here this is root of 2 into S square. Okay, 2 is common. Fine. S square into 1 plus cos of theta. Is that fine? I repeat, magnitude of A, that is S, magnitude of B, that is also S, and here this is what? S square, that is how this S square came out. Now once I take this S square, right, I have 1 and as well as 1 here, so 1 plus 1 is 2, and again I have got 2 here, again that 2 came out, so that is how it is 2S square into 1 plus cos of theta. Now here this is coming as, in the first case, what they are saying is the magnitude is root of 3 times P square plus Q square. So the magnitude is, they are saying that 3 times P square plus Q square. Okay, and what I am having over here is root of 2 into, okay, S square into 1 plus cos of theta. Is that fine? Yes. Now have a look. What is this? Here this is supposed to be P square plus Q square, that is S square. Okay. Yes. Now here this is 2 into, I can write this as what? P square plus Q square into 1 plus, as per this case, what they are saying as theta 1 is equal to 60 degree. Okay. So cos of 60 is what? Cos of 60 is 1 by 2. 1 plus 1 by 2 is 3 by 2. So here this is going to be 2 into P square plus Q square into 3 by 2. This one and this one will cancel each other. So you are going to get it as what? 3 into P square plus Q square, which exactly match with this condition. Are you getting me? That means I can say this particular statement seems to be what? Correct. Okay. Now come to the another. So I will stick to this particular general relation again, and I am going to consider this particular part. They are saying that theta 2 is equal to 90 degree this time. So if theta 2 is equal to 90 degree, cos of 90 is what? 0. And if this part becomes 0, 0 plus 1, it is going to be 1. So this part, while considering theta 2 equal to 90 degree, here this is going to be root of 2 into S square is what? P square plus q square into 1. Basically, this is root of 2 into p square plus q square. And see what they are saying. If theta is equal to 90 degree, they says that the resultant is root of 2 into p square plus q square, which means statement 2 is perfectly correct, isn't it? Statement 2 is perfectly correct. And statement number 1 says, see, theta 1 need to be less than theta 2. Okay, now in that condition, what we need to get into it is, have a look. This is again the general expression. That is the resultant vector r, that is supposed to be root of 2 into s square. S square is p square plus q square. Okay, plus 1 plus cos of what? Theta. This is the general expression. Okay. Now first part says here, this is what? 3 into s square. See, if I take this as s square, that need to be what? Root of 3 into s square. Root of 3 into s square. And the second part says what? Root of 2 into s square. So for this condition to happen, definitely what? Theta 1 need to be less than theta 2. Then only it is possible. Just by considering the trigonometric ratio, you can prove this as well. So based on all these calculations, what we come to the major conclusion is that here statement number 1 is correct, as well as statement number 2 is also correct. So statement number 1 is true and statement number 2 is true. Okay, statement number 1 and statement number 2 both are true. Option 2 must be the correct answer in this case. Okay, so the turning point of this part is understanding that vector p plus q as well as vector p minus q both are having same magnitude. Okay, so we will consider these two as two different vectors because they are acting at different angles. That is why the separation theta 1 as well as theta 2 is existing, isn't it? So we just considered that possibility over here, and we are considering it at an angle of say theta here. Okay, and later on, by considering angle as theta, I am coming to the general expression for what could be the resultant, and this is that general expression. And in this general expression, I am substituting the value of theta 1 as well as theta 2, and finally I am coming to the expression. Theta 1 was 60 degree and theta 2 was 90 degree. So this part 1 plus cos of theta, that got converted to 1 plus 1 by 2 and 1 plus 0 respectively for 60 degree as well as 90 degree, and finally we got the answer. Okay, so here comes the next, that is a block of mass small letter m slides on a wooden wedge, which in turn slide backward on the horizontal surface. The acceleration of the block with respect to the wedge is, that's a question. So let's consider the situation first. Here this is the wedge, and here I am having a mass small letter m, and this wedge is allowed to move towards left with an acceleration of a. Now I am having an observer here sitting. Okay, now with respect to this particular observer, what is going to be the acceleration of this block in the downward direction? That's a question. So here, if I consider this block kept on the wedge, see, the forces acting are, of course, m into g is acting in the downward direction. This angle is theta. So here this is going to be what? mg sine theta, the downward direction. And here we have got what? mg cos of theta. And I have got 0 acceleration for this particular observer who sit here. This frame is moving towards left with an acceleration of a. So of course, as per him, this body is experiencing an acceleration a towards right. So here this is supposed to be what? ma sine theta, and in this direction it's going to be MA cos of theta. I just resolved that. This angle is theta, this one going to be theta, this is 90 minus theta, that is why it is MA sin theta. Now across this line, what is going to be the normal reaction? Normal reaction capital N, that should be mg cos theta, mg cos of theta minus of ma sin theta. Okay, now what is smaller term? It is 8 into g into cos theta is cos of 30, that is under root 3 by 2, minus of m is again 8, small letter a, into sin theta is sin of 30, that is 1 by 2, because here as per the question theta is equal to what? 30 degree. So I just substituted that. So here this is going to be what? 4. So here this is 4 into g into under root 3 minus of here this going to be 4, that is 4 times a, that is normal reaction N. Okay, now this is something very important. This mass of capital M, which is equal to 16 kg, is going to move towards left with an acceleration of a under the influence of this capital N only. And see, have a look, this is theta. If this angle is theta, this one need to be theta. So this is 90 minus of theta. So I can say that N sine of theta, that is responsible for M into a, capital M mass moving with a acceleration towards left. And what is N here? N is this, isn't it? What is N? N can be marked as, capital N can be marked as 4 times g into under root of 3 minus of 4 times a into sin theta is what? 1 by 2. And that need to be equals to what? Mass is 16, I believe. Yes, 16. Okay, into a. So once this 2 comes in, here this is going to be what? 2 times g into under root of 3. Minus this comes in, it's going to be 2 times a. And here this is going to be what? If this, here this is 16 times a. So rearranging this, I can say that g into under root of 3, that's equal to, of course 2 is here, 2 times g into under root 3, here this is going to be what? 18 times a. 18 times a. This one and this one will cancel each other. So it's going to be 9 times a. Okay, we need the value of a from here. So from here I can say that a, that is going to be equal to what? G into under root 3 all divided by 9, which can be written as what? 3 into 3. This one and this one will leave root 3 on the denominator. So acceleration a, that's equal to g upon 3 root of 3. G upon 3 root 3, that is the acceleration. Now again let's go back to the wedge. This is that mass, okay, and this is the observer, and here this is having g sin theta plus a cos of theta. This is the downward acceleration as per this observer. Okay, which means that acceleration a bar, that's going to be g sin theta. G sin theta is g by 2 plus acceleration a, we got it as what? G upon 3 root 3. Okay, g upon 3 root 3 into cos of 30 is root 3 by 2. Root of 3 by 2. Root 3 and root 3 will cancel each other. Now here this is g is common and I have got 1 by 2 plus 1 by 6. Okay, so multiplying with 3 here, as multiplying with 3 here, 3 plus 1, it is 4. So it's going to be g into 4 by 6. Okay, so this is going to be what? 2g by 3. It's 2g by 3. That means option 4 must be the correct answer in this case. Alright. Now let's move to the next, that is question number 12. Question number 12 says, an object of mass small letter m, is moved with a constant velocity under the action of an applied force 2 Newton along frictionless surface with the following profile. Okay, so we need to identify the correct applied force versus distance. I repeat, force versus distance. So if you closely watch this body is moving up and after that coming down, speed remains the same. So if I understand this upward motion first, so of course you all know that the forces acting over here, it's going to be normally action n is going to be the upward direction, okay, and m into g is going to be in the downward direction. So we all know if we want to apply, if we want to move this with a constant velocity, this is going to have mg sin theta component here and mg cos theta component here. Alright, so definitely we must have force F in the upward direction by somebody. Now this is a case where this can move in the upward direction with a constant velocity. Now the problem over here is, see the graph. So the graph says here the force is increasing to 2 Newton and after that decreasing. Here it says that it remains 2 Newton only, okay, and all of a sudden it will reverse and will become a minus 2 Newton, and it's decreasing towards 2 Newton and increasing towards 0, and here it is minus 2 Newton in the beginning and plus 2 Newton towards the right. Okay, now as per this case what they are saying is we are applying a constant force of 2 Newton. Okay, now come back to this. If I want to apply a force of capital F here, see the body is moving towards, if the body is starting from here to here, the body is moving towards right, and after that again body is moving towards right. But the point over here is, first of all the force is acting in this direction while taking it and reaching to the top, and second case while coming down the force is acting in the opposite direction. Alright, so if I consider the horizontal component of these forces, okay, to understand how it was moving along positive x-axis direction as well as negative x-axis direction, I can have the components like this. I can have capital Fx towards left, okay, because in the upward direction, sorry, it's going to be capital Fx towards right first, Fx towards right, Fy towards the upward direction, and of course n of y towards left and n of x in the downward direction and mg in the downward direction. If I consider the motion in the upward direction, and while coming down, what happens here is the forces are acting in this way. The normally action in this direction, F in the upward direction and mg like this. So mg remains as it is. Mg remains as it is. Okay. Now if I consider, see, n of x is going to be towards right, n of y is going to be in the upward direction, okay, n of x is in the horizontal direction and n of y is in the upward direction, and here I was having n of x like this and n of y like this, isn't it? N of x, sorry, n of y in the upward direction and n of x in the negative direction, and here n of x is in the towards right and n of y is in the upward direction, and here I have got f of x towards left, isn't it? Because I am having the force in the upward direction. So f of x in the negative direction and f of y in the upward direction. Is that clear? Okay, now comes the most important part. Theta is same for both. Okay, so the normal reaction is going to be same for both. So once normal reaction is same for both, nx as well as ny is going to be same for both. F is 2 Newton throughout the motion. So there also f of y as well as f of x, that is going to be same for both. Okay, but while comparing these two, what you can see over here is, see, mg is in the downward direction, mg is in the downward direction. N of x towards right, n of y towards left. Here n of x towards left, n of y the upward direction. So n of y and n of y is going to be the same thing only. N of x as well as n of x is going to be the different, but just because of the inclination. And while looking onto the part of capital F, here f of x is towards right and here f of x is towards left. F of y in both the case remains the same, which means throughout the motion from here to here, we need the support towards what? Support towards right. That means positive it need to be. And while moving from here to here, we need the role of capital F in the negative direction. That means capital F need to be negative. Now try to understand the graph. In the motion starting from small letter A to small letter B, we want force in the forward direction. That means positive. So we want that to be positive, yes, and constant, positive and constant. And then from here to here, it need to be positive, it need to be what? Constant, and need to be negative. So only this could be the graph that support how capital F varies with respect to capital D. Here it's constantly varying, not possible. Here constantly decreasing and increasing, not possible. Here this part doesn't satisfy the direction of F. That was it. Okay. Now if we move to the next, that is question number 13. Question number 13 says, when a body slides down from rest along a smooth inclined plane, making an angle 30 degree with the horizontal, it takes capital T time. And when the same body slides down from rest along a rough inclined plane, making same angle through the same distance, it takes time capital alpha times t. In the first case, it's taking capital T, and second time it's taking alpha times capital T. Definitely alpha need to be greater than 1. Now, the coefficient of friction between the body and the rough plate is given as 1 upon root of x into alpha square minus of 1 upon alpha square, and from here we need to get the value of capital T. The most important part given over here is we have got a relation between capital T, T1 and T2. T1 is the time when the body was sliding down without any friction, and T2 is that time when there is a friction. And T1 is marked as what? T1 is marked as capital T, and T2 is marked as what? Alpha times capital T. So this is the most important part here. Okay, now let's see how to proceed. So this is the wedge, and it is traveling through same distance. So S is same for both. So if I consider the case where there is no friction, then I can write the equation as S is equal to, since the body is starting from rest, ut term will become 0 plus half of acceleration here is what? G sin theta into T1 square. So basically T1 square is now equal to 2 times S upon G sin theta. In the same way, I can say that T2 square, that is going to be 2 times S upon upon g sine theta minus of mu times g cos theta. Here this is retardation because of friction, that is T2. So from here I can say what is T1? T1, that is equal to root of 2 times s upon g into sine of theta. And what is T2? T2 is equal to root of 2 times s upon g sine theta minus of mu g cos of theta. Okay, and we know that T2 is equal to T2, that is equal to alpha times T1, isn't it? Alpha times T1. So I am going for that. Okay, so here what was T2? T2 we got it as root of 2 times s into g sine theta minus of mu times g cos of theta, that was T2, and that is equal to 2 times T1, sorry, alpha times T1, that is alpha into what was T1? 2 times s upon g sine of theta. Here this is T1 and here this is T2. Let me square both the terms. Okay, so here this is going to be what? 2 times s upon g into sine of theta minus of mu times cos of theta, that's equal to alpha square into 2 times s upon g sine of theta. 2s and 2s will cancel, g as well as g will cancel. Now what I have left here is 1 upon sine of theta minus mu cos theta, okay, that is equal to alpha square upon sine of theta. Okay, now what is the inclination? Inclination is 30 degree. So let's take the advantage of that information. So here if I consider, I can have 1 upon, okay, sine of 30, that is 1 by 2 minus, let's do it in a different way. We need the value of mu, isn't it? So once we need the value of mu, let me rearrange this first. So here this is going to be sine of theta, okay, that is equal to, or I can say sine of theta by alpha square, sine of theta divided by alpha square, that is equal to sine of theta minus of mu times cos of theta. Okay, on rearranging this I can say that mu times cos of theta, that is equal to sine theta is going to be common into 1 minus of 1 upon alpha square. So now here this is going to be mu into, what is cos theta? That is root 3 by 2. Cos of 30 is root 3 by 2. That's equal to sine theta is 1 by 2 into, here this is what? Alpha square minus 1 upon alpha square. Alpha square minus 1 upon alpha square. Okay. So here this one and this one will cancel each other. So what is mu now? Mu is equal to 1 upon under root of 3 into alpha square minus of 1 upon alpha square. And here it is 1 upon root of x into alpha square minus 1 upon alpha square. So it is evident that x equal to what? 3 from this relation. Alright. Now let's move to the next, that is question number 14. Question number 14 says, in the arrangement shown in the figure, A1, A2, A3, A4 are acceleration of masses m1, m2, m3 and m4 respectively. Which of the following is true for this arrangement? So if I mark this as T, so this one is also going to be what? T. So here this is going to be 2 times T and here this is 2 times T. Here this is what? 4 times T and here also it is going to be what? 4 times T. So from here From here itself I can go for the relation as 4 times A1, isn't it? 4 times A1 plus 4 times A1 plus, here this is what? 2 times A2. Acceleration of this one is going to be 2 times A2, okay, plus A of 3 should be equal to 0. A of 3 as well as A of 4. A of 3, yeah. A of 3 plus A of 4. Constraint relationship. Here this is T and here this is also T. Yes. A of 4 should be equal to 0. From here itself it's clear. Okay. M1, M2, M3, M4. Yes. So here it's 4A1 plus 2 times A2. Because it's 2, na? Yes. 2 times A2 plus A3 plus A4. That means 4A1, 2A2, 4A1, 2A2, 4A1, 2A2. Option A must be correct answer. It's constraint relation. Basically, we need to look onto the tension acting and we can connect tension as well as acceleration there. Now, let's move to the next. That is question number 15. 15 says, a system of 2 blocks of mass 2 kg and 8 kg is placed on a smooth table as shown in the figure. The coefficient of static friction between the block is 0.5. That means between these two only we have got a friction. Okay. Now, the maximum horizontal force capital F that can be applied onto the block of mass capital M so that the block move together will be. That's a question. So, altogether the mass is 10. So, 10 into A towards right, that's supposed to be what? F. The force F. Now, A is equal to what? F upon 10. Now, if I consider the free body diagram of small letter m. So, small letter m managed to move in the forward direction because of small letter f, that is friction. And what is the maximum value of friction possible here? Maximum value of friction possible is supposed to be mu. Mu is what? 1 by 2 into m into g. M is what? 2 and g is 9.8. So, this one and this one will cancel each other. So, F max is equal to 9.8. That is supposed to be equal to what? That is supposed to be equal to m into A. M is what? 2. Alright. And what is A there? A is F by 10. F by 10. Okay. So, here this is supposed to be capital F equals 98 divided by 2. Alright. Here this is going to be 98 divided by 2. And that is supposed to be what? 49. Option C must be correct answer in this case. Was that fine? Now, let's move to the next. That is question number 16. The question says, a block of mass 2 kg moving on a horizontal surface with a speed of 4 meter per second enters a rough surface ranging from x equal to 0.5 to x equal to 1.5 meter. The retarding force in this range of rough surface is related to the distance by F is equal to minus of k into x, where k equal to 12 Newton per meter. Then they are asking for the speed of the block as it just crosses the rough surface will be. So, let us consider the situation like here x is equal to 0.5 and let this be x equal to 1.5. And what's the body enter here? Once the body enter here, it was having a speed of what? 4 meter per second and the mass of the body is what? 2 kg. And this is experiencing a retardation and the force experienced is what? Force experienced is given as minus of k into x. So, the magnitude I am marking it as what? K into x. What is the value of k? K is given as 12. So, I can mark it as what? 12 times x. That is the force acting. Mass of the body is 2. So, acceleration A, that's going to be 12 into x divided by mass is what? 2, I can say it as what? 6x, that is acceleration. And we all know that acceleration A, that is equal to v into dv by dx. Here it is decreasing, so that I will be mark it as minus. Alright, okay. Now here, what is A? A is given as 6 times x. This will come to the left. So 6 times x into dx, that is equal to minus of v into dv. Minus of v into dv. And we need to find out the final velocity here. Initial velocity is given as what? 4 meter per second. We don't know what is the final velocity. So what is final velocity? That is the question. And we have got this expression. Okay. Now, just consider it here. If I integrate this, here this is going to be integral of 6 times x into dx between the limit x equal to 0.5 to x equal to 1.5. That is going to be minus of integral of v dv between the limit, initial velocity is what? 4. While entering it was having a speed of what? 4. Okay. And final velocity, we don't know, we need to get it. So here this is going to be what? 6 into, it's going to be x square by 2 between the limit 0.5 to 1.5. That's going to be minus of, here this is v square by 2 between the limit 4 to capital V. And this is what we need to find out. So here this is going to be 3. So 3 into, while substituting the limit, here this is going to be what? 1.5 the all square minus lower limit is 0.5 the all square. That is equal to minus of 1 by 2 into upper limit is v square minus lower limit is 4 square, that is 16. Okay. If I multiply with 10 and divide with 10 here, and here also multiplying with 10 and dividing with 10, 10 square is 100. So it's going to be 3 by 100. And here this is 15 square, that is 225. And here this is 5 square, that is 25. That's equal to minus of 1 by 2 into v square minus of 16. Alright. So here this is going to be 50. And 225 minus of 25, that is 200. So 3 upon 50 into 200 here. That is equal to minus of v square minus of what? 16. Isn't it? Minus of v square divided by 16. So of course here this is going to be what? 4. 4 3s are 12. Now here this is 12 equal minus of v square. Here this goes in, that's going to be 16. So of course this will come to the left. So this is now going to be 4 equal to what? V square, and v is equal to what? 2 meter per second, which means option C must be correct answer in this case. Now let's move to the next, that is question number 17. The question says 3 masses, capital M equal to 100 kg, okay, and M1 that is equal to 10 kg and M2 that is equal to 20 kg are arranged as a system as shown in the figure. All the surfaces are frictionless and the string is inextensible and they are weightless. The pulley are also weightless and frictionless. Force capital F is applied on the system so that the mass M2 moves upward with an acceleration of 2 meter per second square. Then the value of capital F is. It's a very important question. Let's try to understand the situation here. So here this is the block, okay, and I am having a pulley here, and I am having a mass attached, and I am having a mass kept here as well, okay, and this is 20 kg and this one is 10 kg, and here this is 100 kg. And as per the question, 20 kg mass is accelerating upward with an acceleration of 2 meter per second square. Isn't it? 2 meter per second square. All the string are inextensible, and I am applying a force capital F here. Capital F is here. So here this is moving up with an acceleration of what? 2. So here this also must be what? Moving towards left in an acceleration of 2 meter per second square. Okay, yes. Now, if I consider the horizontal motion, which all masses are going to move along horizontal direction with a particular acceleration which is common for both. Which all mass will be moving? Please, let's discuss about that first. Of course, this mass will be moving towards right, as well as this mass also will be moving towards right in the horizontal direction. So, the masses that is moving towards right with a common acceleration is 100 kg and 20 kg. Okay. Now, what are the forces acting? For this system, if I consider, see, if capital T is marked as tension here, here is also going to be capital T. So, if I consider this total mass, that is how much? 120 kg. So, 120 kg mass is moving towards right with an acceleration of A. We don't know what is that acceleration. And that is by the virtue of this force capital F minus the horizontal force acting in the opposite direction is capital T. Okay. Now, let me consider this person is standing here. So, this entire system is moving towards right with an acceleration of A. As per this person, as per this particular person, this is moving towards left with an acceleration of what? 2 meter per second square. Okay. Now, just have a look. So, this 2 meter per second is what we connecting it from acceleration of this one. Now, for this person, this mass, that is 10 kg. Let us consider the free body diagram of 10 kg mass with respect to the person who is on the block of 100 kg mass. So, there, if I consider that mass, that is that 10 kg mass, of course, we have got that T tension acting towards right, and he is on this frame. This frame is accelerating towards right. So, zero acceleration is going to be towards left. Isn't it? Now, this acceleration is also there. That means the acceleration of this one, that will also be appearing there. So, that is what? 2 towards left. Okay. Now, if I consider, so these are the accelerations I am just marking. Alright. So, this was going up with an acceleration of 2. That is why the same acceleration is reflecting here. Now, this entire frame is accelerating towards right. I repeat, this entire frame is accelerating towards right, and that is why this zero force is acting towards left. So, I can write for this one m into, that means mass is what? 10. So, 10 into 2 towards left. 10 into 2 towards left, that is equal to m into a. Zero acceleration was m. So, m into a towards left, and what is m? M is 10. 10 into a towards left, okay, 10 into a towards left minus of capital T towards right. I got the expression for this one. I repeat that for that mass 10 kg, I repeat the forces acting. Zero force is acting towards left, that is m into a. Tension T is acting towards right, and as a result of that, this was moving with an acceleration of 2 towards left. So, 10 into 2 towards left, that is equal to 10 into a, that is zero force towards left minus T towards right. Now, if I consider the horizontal motion of this mass, 2 kg mass, it's moving up with an acceleration of a. Isn't it? Not 2 kg, 20 kg. 20 kg mass is moving up with an acceleration of 2. So, 20 into 2 in the upward direction, that is equal to T in the upward direction minus of 200 in the downward direction. I repeat, 20 into A upward, that's equal to T in the upward direction minus of what? 200. So from here, what is capital T? Capital T is equal to, of course, this will come towards the left. Here this is 200 and I have got 40 here. So capital T is what? 240. Capital T is 240. Now let me substitute that here. If I substituted that value, here this says 20. That was equal to 10A minus of capital T, we got it as what? 240. So this will come towards the left. 240 plus 20, that is 260. That's equal to 10 times A. This one and this one will cancel each other. A is equal to what? 26. A is equal to 26. And what we need is, we need the value of F. So if I consider this equation, 120 times A, that was equal to capital F minus T. 120 times A, that's equal to capital F minus of T. What is A here? A is 26. So 120 into 26 plus capital T was 240. 240 is going to be capital F. Okay. Now 26 into 12. Let me go for that first. 26 into 12. Here this is going to be 6 2s are 12. 1, 2 2s are 4. Plus 1 it is 5. And here this is 26. So here this is 2. And here this is 1. And here this is 1. So it's 312. And while considering the 0, it's going to be 3120. So 3120 plus we have got 240 here. 240 here. Here this is 0, 4 plus 2, 6, 2 plus 1, 3, and here it is 3. So the final answer is going to be 3360. It is going to be 3360, which means option A is going to be the correct answer in that case. Alright. Now let's move to the next, that is question number 18. Question number 18 says, a monkey of mass 50 kg climbs on a rope which can withstand tension capital T equal to 350 Newton. Okay, this is the maximum tension that the rope can manage. If the monkey initially climbed down with an acceleration of 40 meter per second square and then climbs up with an acceleration of 5 meter per second square, choose the correct options. We need to take G equal to 10 meter per second square, and option says capital T equal to 700 Newton while climbing up, T equal to 350 Newton while going down, rope will break while climbing upward, and rope will break while going downward. These are the 4 options. Okay, now 350 is the mass. Okay, 350 is the 350 is the tension that the string can withstand up to the max. And just imagine, if the monkey simply hanging from the rope, which means it's going to be 500 Newton weight. So if simply hanging, the rope will break. So if they're simply hanging, the rope will break. That means while moving the upward direction, what? It will definitely break. So the rope will break while climbing upward. That's the correct answer. That's the correct answer here. Alright. So more than one option is not at all. More than one option, that means like A, B, C, D. I mean that combination is not at all here. So we can log this is the correct answer. Now let's check the correctness of the remaining part. Option A says capital T Newton while climbing upward. See, understand one thing. This rope can withstand up to 350 only. Okay, even then, for your understanding only, I am telling about this. If this rope was able to manage a tension which is much greater than 350, and anyhow it ensure that this monkey is climbing in the upward direction. Just imagine like that. Then what could be the value of tension? In that case, I can assume the situation like this. Let this be the rope. Okay, and let this be the monkey climbing up. So I can say mass of monkey into acceleration of the monkey in the upward direction, that need to be what? T in the upward direction minus mg in the downward direction. Now mass of the monkey is what? 50, and the acceleration while climbing up, isn't it? While climbing up, the acceleration is marked as 5. Okay, so 50 into 5, that is supposed to be capital T minus of, here this is going to be 500, here this is 250. So here capital T is supposed to be what? 500 plus 250, that is 750. That means if we used a rope which was capable of handling the upward climbing of the monkey, then the tension developed should have been 750. Okay, not 700. See, the first thing is that this string won't be available there to get this value, but if a string was provided which can withstand a tension, then it should have been 750, not 700. Okay. Now, for what's the case while coming down? While coming down, mass is again 50, and while coming down, it is acceleration is what? While coming down, the acceleration is 4. That is equal to downward force. That means the weight, that is 500 minus tension T upward. So capital T is supposed to be, here this is 500 minus of 200. Here this is 200 only, isn't it? So this should have been what? 500 minus 200 is 300, and what they are saying is 350. It's 300. So I already told you which is the correct answer. Okay, and this was just a further verification for the same. Now let's move to the last question for this session. That is, a bag is gently dropped on a conveyor belt moving at a speed of 2 meters per second. The coefficient of friction between the conveyor belt and the bag is 0.4. Okay, now initially the bag slips on the belt before it stops due to the friction. Now the distance is, basically what happens is, this is the conveyor belt, okay, and here this is the bag. So initially bag was moving with a speed of v because it was just slipping. So frictional force is acting in the opposite direction. So gradually this speed will be reduced, and finally with respect to the belt, it will be moving towards right. From the observer outside, it will be moving towards the right, and with respect to the belt, it's going to be at state of rest. That is why both are going to move with the same speed. So the point is, what is the distance traveled by the bag with respect to the belt? That is a question. So basically we can go for the same equation that what we know, v square equal to u square plus 2as. Okay, this friction will be finally causing the value for v to be 0, and what was u square? U square is 2 square, that is 4, minus of 2 into, okay, now comes the point, what is acceleration here? Acceleration is supposed to be mu times g, and what is mu here? Mu is 0.4, I can write it as 4 by 10, okay, and here we have got the liberty to take g also as what? 10, and here this is going to be s. So this one and this one will cancel each other. Okay, now 4 2s are 8. So 8 times s is equal to 4. So s is equal to what? 4 by 8, that is 1 by 2, answer is 0.5 meter, which means option B should be correct answer. So that is all from my end for this time. Take care and bye bye.